Good morning. Happy Monday. I hope everybody had a glorious weekend and did not get washed away. We had some pretty wild weather. I hope your properties survived the torrential downpour. It came hard and fast and was a little bit relentless and the kids thought, oh, we'll just go quadding for a little bit. And then the rain came and the lawn got ruined and they had to quick hide. So hopefully everybody is okay. This Monday morning, waking up, I'm not going to lie, I put a scarf on. I was a little bit cold, but if you are indoors or maybe you're driving and you're behind the glass because the sun is shining now and it's cozy. It is a nice Monday. I am excited for the fall season. I love the changing of the colors. It's hard when it's so drastic. It's hard when it's 27 degrees and then it's 11 degrees. But I hope everybody had a restful weekend, whatever you were doing, that it was rejuvenating and you're ready to jump back into class today. My name is Kobe Flatt, and for the next 50 minutes, we're going to be going through the MAP4C Grade 12 Foundations for College Mathematics course. We are just beginning week 6 of our 9-week radio Zoom schedule. That means that we are going to be wrapping up Unit 3 here shortly so that we can get Unit 4 in and then some review. I have in the past and was planning on doing a unit review after every unit. So we finished the first 5 lessons and we did a Unit 1 review. We finished the next 5 lessons, lessons 6 to 10, and I skipped the unit review because I feel like I want to make sure that we get all of the course material in, that we're covering all of the concepts so that you have an understanding of how to do each lesson. Then, if we've got time at the end, I would love to do a full course review looking at each unit so that you are prepared for our final assessment for that open book exam that's going to take place at the end. Remember, you complete all 20 lessons, and if and when you do so, when you hand them in, you get your name put into a draw for a chance to win a prize. Then you do the final assessment. So some courses have a culminating activity. This course has an open book exam. And then when you successfully obtain that, you get the credit. And then your name gets entered into a second draw for a chance to win another prize. So keep that in mind. Know that we are coming to the end of our radio Zoom term. Term 1A just goes until October 31st. You can be handing in work on October 31st in order for it to count for this term. But remember, we only broadcast Monday to Thursdays, so our last on-air class will be Thursday, October 30th. That gives us about 3.5 weeks. Next week is a short week with the Thanksgiving holiday on Monday of next week. But let's focus on what we can manage this week, what we can do. We're going to jump into Lesson 12 as soon as we go back and briefly look at the end of Lesson 11. Lesson 11, we talked about survey design. We looked at sample size, what is a representative sample, what are sampling techniques. We looked at random, non-random. We saw that there were multiple ways to write questions. There were various methodologies that included an interview method, telephone survey, mail survey, email survey, intranet surveys. We saw how to word questions in your questionnaire and to use the acronym KISS, keep it short and simple. And we looked at some question types, open-ended text, open-ended numeric. We looked at how to create a survey online using just one tool. We just looked at Google Forms because that's what all of our students have access to on G Suite. And we didn't get a chance to wrap it up with the question and answer choice order. I want to touch on that now before we jump into lesson 12. It's important to note when you're designing your survey that how you present your data can have an effect on your readers as to what information they glean from it. We looked at how if you use a pie chart versus a bar graph versus 3D versus, it can all elicit a certain assumption and how they read the results. When you are laying out your survey, it's important to keep in mind the bias of the wording. You don't want leading questions that we talked about, but we also need to be careful about order choice because that really plays a role, and it's important to consider a few things. First, how the question and answer choice order can encourage people to complete your survey. Secondly, how the order of questions or the order of answer choices could affect the results of your survey. We're saying that questions should typically start easy and get progressively more difficult. If you're given a survey and the very first question is hard, it's thought-provoking, it requires time to consider, you are most likely going to turn your respondents off from going any further. It will shut them down and they won't want to bother with it. But if you start easy and you get them going, then by the time it comes to the end and you've got more difficult questions, they're more likely to continue answering because they've already invested a lot of time in this. So they're going to take a few more minutes to think of those difficult questions to then respond so that they can be done. Easy and pleasant questions, therefore, encourage people to continue the survey. You do typically want to group questions of the same topic together. When we were on Google Forms last week, you can split questions into sections. You can have a section on personal information, a section on work information, a section on school. You can group them so that you have questions of the same topic together. Remember to leave difficult or sensitive questions to the end because people are more likely to answer once they've already invested their time. Rapport should be built. Ideas of the topic are flowing. If people quit, if it's an online survey or questionnaire, then even if they quit, you can often get the results to the majority of your questions. Now, if it's a mail survey and they've just done a few at home and they haven't mailed it out yet, then you're not going to get anything. But if you can do it online and you can capture, if you can have like a save sort of button that they can send without finishing, if they're not required questions. When we went through our Google Forms last week, we showed that you can make some questions required and then you get that little red asterisk, that little star that says they have to answer it. If you have questions that they don't have to answer, they're more likely to submit it half finished. And then at least you get something out of it. Question order has an important role, and when we look into what questions are asked and in what order, we see that results can be affected by two main things. The first is planting of an idea. The second is habituation. When you are planting seeds, it usually comes from once something is mentioned, whether it's an idea, an issue, or a brand in one question, it can make people think of it again when they answer a question later. We don't want to be leading, so we can avoid this. It can be reduced through separation or randomization. If you're putting the questions farther apart, not clumping them together, then they're more likely to forget about it or it not be so prevalent or readily answered similarly to another one that you did. Habituation is if you have a series of questions that all have the same answer choice, people will begin to answer habitually. That's out of habit. Without even reading, they're just going to give the same answer without thinking on it, without reading the question completely. It's just going to be, oh, it's this, it's this, it's this, it's this. And we want to avoid that if we want real answers with a strong correlation. I wanted to make sure that we got that in there so that you understood more about survey design. Today we are going to focus on lesson 12, where we're talking about the media and data management. We're going to explore how the media uses data to inform the public. We will better understand how to interpret information that we see in the media. Remember, the whole point is we want to be educated, we want to be knowledgeable about statistics and data so that we can be better informed and critical thinkers so that we're not just being spoon-fed what we're told, but to actually think, is this true? Is this what I believe? We want to be able to decipher information as it comes our way. So our learning goals for this class are that we will be able to interpret statistics, that we will be able to understand the role of data management as used in the media, advertising industry, and various occupations. If we stop to think about where the majority of our information is coming from, you might come to the conclusion that the media is the primary method of informing the public. There is a graphic that I have on the board in front of me that comes from Statistics Canada, and it shows media consumption in Canada. Are Canadians in the know? Following the news is an activity that more than half of Canadians do on a daily basis. They watch the news through some form of a platform, an outlet, or another. There are different ways to follow news and current affairs. Using data from the 2020 General Social Survey on Social Identity, this infographic explores 5 different news sources. It has newspapers, magazines, television, radio, and the internet. Those are our 5 sources. A study was conducted and it was found that the most common method for following news and current affairs was the internet at 80%, followed by television at 67%. Those with a university degree were more likely than those with no university degree to report using the internet, newspapers, and magazines to follow news and current affairs. So we have all of these statistics in this one infographic that's letting us know how Canadians are keeping informed. There's a fun little fact that says the internet was most popular among those aged 15 to 34, while those 55 years of age and older prefer television to follow news and current affairs. We can get a huge understanding of media consumption based on, here we can see gender, we can see age, we can see ethnic, race, we can see how it's presented in bar graphs, in different, like a kind of like a pie graph. If we're looking here at among immigrants, the more time they were in Canada, the more they used media to follow news and current affairs daily. And it shows sort of this wheel of percentage. So here's one, I don't want to say the little segue into, but it's a segue into the media and data management. We are going to be talking more about the term statistics, sample, and sampling technique. So a quick reminder, since we've had the weekend in between, statistic is a piece of data from a study that is part of a large quantity of numerical data. Sample is that representative number of participants in a study. Sampling technique is the process used to select the individuals from a population who will be studied. Bias, again, is that emphasis on characteristics that are not typical of the entire population. Validity refers to the accuracy of a measure. That's how well true findings are represented. And reliability refers to whether or not a measure is consistent. Can it be replicated and reproduced under the same conditions? So looking at statistics in media, television, radio, newspapers, and websites often report statistical data. We saw this from Stats Canada infographic. In order to understand these reports, you need to be familiar with statistical language that they use. Luckily, when Stats Canada is presenting something, they often use terminology that we can follow, that we can understand. But sometimes, if we want to delve deeper or use a different source, it does get a little bit more in depth. So we want to be familiar with the terminology. One term you might come across is percentile. Percentile tells approximately what percent of the data are less than a particular data value. Percentiles are a good way to rank data when you have a lot of data, or if you've got data that you want to keep private. Then you put it in terms of this percentile scale. Another term is quartile. Quartile is any of three numbers that separate a sorted data set into four equal parts. If you're following along on the board, you see I have this data set of numbers: 2, 2, 4, 5, 5, 5, 8, 9, 9, 9, 12. So here are our 11 numbers. And when we're looking at quartile, we're looking at dividing them into those equal sets into four equal parts. So first, we have our first, we have our second, our third, and our fourth. That first quartile, that Q1, or also known as lower quartile, represents that first set of data. The second quartile is the median. It's right in the middle. You can see how it splits our data. That's the second quartile. And then the third quartile is that upper quartile. It's everything sort of to the right of. So what does that mean? Let's look at it in a little bit more depth. The first quartile, or the lowest quartile, the median of the data values are less than the second quartile. That's our middle, that's our median, remember? So the first quartile separates the lowest 25% of the data. It's a quartile, like a quarter. There's 4, 25 the 4 in 25 increments. When you think of it as like a loonie or a whole and a quartile, we have the quarters, and a quarter is 25 cents. You can remember it like that. So the first quartile is the lowest, therefore it represents the lowest 25%. Therefore, we can say the 25th percentile. Now the second quartile is the median. It's right in the middle. It cuts the data set in half. So that's the 50th percentile. And then the third or upper quartile, the median of the data values greater than the second quartile. So if we're looking at a set, this is kind of our neutral, that median. Anything below is the first quartile, anything above is the third, and our second is right in the middle. So it separates the highest 25% of the data set. Therefore, it is the 75th percentile. So when you see the term quartile, and if it's the first quartile, you'll know it's the lowest 25%. Second quartile is that median, it's the 50th percentile. And the third quartile is the highest 25%, so we can also say the 75th percentile. So they work hand in hand, percentiles and quartiles. To help make a little bit more sense of it, I have an example on the board in front of me that says here are the hourly pay rates in dollars for 17 high school students with part-time jobs. So sometimes this is sensitive information. You don't need to know who's being paid what. It's often a sensitive issue. So we put it into a data set that organizes it into percentiles. This question is asking, what are the quartiles for this data? So what you want to do is you want to find the range. We want to set it up so that we can find where the quartiles are. So in order to find the quartiles, you just order the data. You line them up in numerical order and find the median. Remember, the second quartile is the median. It's what cuts the data set in half. So on the board, we have a table that has $11.50, $9.75, $10.75, $10.20. It's all of the hourly pay rates for these 17 students. So we have 17 data points. There is an hourly pay rate for each student. And I'm wondering if I put the number there. I did put the number line. So I made this number line to save time so that I can get all of lesson 12 in today, because tomorrow's lesson 13 is going to take us 2 classes. So having done that fast forward time lapse, pretending that we're baking something, here we have the data points all lined up in front of me. The lowest hourly pay rate is $7.50, and the highest hourly pay rate is $13. So what are the quartiles for this data set? Well, since the second quartile is the median, it cuts the data set right in half. We're going to look for that middle point. Whereas in 17, we have 1, 2, 3, 4, 5, 6, 7, 8 data points on one side, and that means we have 1, 2, 3, 4, 5, 6, 7, 8 data points on the other side. So our second quartile is right in the middle, and on our numerical line, that median is $9.45. So that is our second quartile. It's easier to start with that. So then we look at our first quartile, which is the lower quartile. Remember, it's the data values that are less than the second quartile. We have to look at the ordered data that's less than the second quartile. So we have the $7.50, $7.75, $8, $8.25, $9, $9.15, $9.25. You could add them all up and divide them by how many there are. And since there are 8, you divide by 8. And that would give us the mean for that average for how the lower quartile, where it sits at. So we can say, and I've done the work for us to save time, we can say that that lower quartile is $8.13 an hour. So we have our second quartile, $9.45, our first quartile, $8.13, and then you do the same for the third quartile. It's all the data values that are greater than the second quartile. So now we're going from $9.50, $9.75, $10.20, $10.75, $11.25, $11.50, $12.50, $13, divide it by 8, and we get $11. So our third quartile is $11 per hour. We can find what our quartiles are by lining up the data in numerical order, going from lowest to highest. From there, we are going to move on to part B. So here are the hourly pay rates in dollars for 17 high school students with part-time jobs. It's the same table. This part of the question says Damien's pay is in the 85th percentile for this group. What does the percentile mean, and what is Damien's hourly pay rate? So it's important to go back and think of our terminology. Percentile, if we remember, and I'm not sure I'm going to write the whole thing. Let's see. Percentile tells approximately what percent of the data are less than a particular data value. So if percentile is approximately what percent of the data are less than a particular data value, then the 85th percentile means that approximately 85% of the students in the group earn less money per hour than Damien. So if we really wanted to, we could find out what is Damien's hourly pay rate. Thinking of, there are 17 students. So if we do some math, there are 17 high school students. And we want to find Damien, who is at the 85th percentile. That means that we could find what Damien's hourly pay rate is by first converting 85% to a decimal. Remember, when we're going from percentage to a decimal, we want to divide by 100, so we move the decimal place. We get 0.85. So we could say 17 times 0.85 to find out what the hourly pay is for Damien. If we do 17 times 0.85, decimal, there we go, 85, we get, and I'm going to go back to here, we get 14.45. So that's saying that 14 people earn less than Damien. So if we say 14 people earn less than Damien, we could use our number line to show where on the order list, and did I pull that one up? No. If we were to go back and pull up, here we are, our numbered list, we would see that Damien is 15th in the order list. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Damien would be 15th on our order list, which in our numerical number line, when we line it up, means that Damien is making $11.50 per hour. Therefore, Damien's hourly pay rate is $11.50 per hour. So we do use percentiles to keep data private and secure, but if you're a mom, maybe you remember your kids were born and you have to take them for a lot of appointments when they're younger, and you're bringing them in, they measure their head size, the circumference, they measure their weight, and they tell you, oh, your kid's in the 85th percentile. And you think, well, is that something I should be excited for or worried for? it's hard to know if you don't understand the terminology. And so, like Damien, you can find out what an individual's hourly pay rate is. If you lined them all up, you could find that one. But it still doesn't tell you who gets paid the lowest. It is still sensitive information because we don't know who's making the $7.50 and we don't know who's making the $13 an hour. But it helps you to recognize how to understand quartiles and percentiles and finding that, yes, if you're in the 85th percentile, you are earning higher because a percentile means approximately what percent of the data are less than a particular data value. So it can help you to gauge what side of the scale you're on, so to speak. As we were trying to find quartiles and what each quartile was, and I used the average. We worked last week on mean, median, mode, just reiterating what they are because sometimes it's been a while since we've done them and it can be a little bit confusing. And because we're talking about the media and data management, it is important that you recognize the difference between mean versus median. They can often get confused. Which one's mean, which one's median? Aren't they the same? They're pretty close. Both are measures of central tendency, meaning that the values are intended to represent the middle of the data. But it can be done in different ways, and that is what is important to understand. To find the mean, or the average, you add together the value for every member of a group, and you divide it by the total of members. So that's what we did with the quartile. We added up all the individual data sets, and then divided by how many there were. That gives you the mean. The median, on the other hand, represents the value that's in the very middle. So on the board in front of me, I have a graphic that shows median versus mean. Median versus mean. Median is you line them up from lowest to highest, and whoever's right in the middle, that's the median. And that's what we did for our second quartile. Now for mean, we are adding them all up and dividing by how many there are. That gives you the mean, or that average. Because we're running out of time, I want to make sure that we get our data in. So I'm going to skip the next example that I had and talk about data reliability. When you are presented with statistical data, consider the reliability of a source. Remember our definition? Data from government agencies are usually more reliable than data from sources trying to sell a product or promote a certain point of view. When we looked at our first infographic, it came from Statistics Canada, which is a pretty reputable source. Now, when we're thinking of somebody trying to sell us something, push an agenda, or promote that certain point of view, we have to be careful about its reliability. Let's practice by thinking of a few examples. I've got one on the board that says, in each case, a research topic and two sources of information are described. Decide which data source is more likely to provide a reliable set of information, reliable data. If our topic, for instance, is talking about the benefits or adverse effects of drinking milk, would we go to a source that, say it was a pamphlet from an animal rights group that opposes dairy farming? If I want to know the true and honest benefits or adverse effects of drinking milk, would I go to an animal rights group that opposes dairy farming? Am I going to get an accurate sense of information, are they going to be reliable or are they going to be pretty biased and one-sided? My second source is Canada's Food Guide, produced by Health Canada. Who is more likely to give me the true data, the reliable data that I'm going to need in order to make an informed decision? If you said Canada's Food Guide produced by Health Canada, you are correct. It's those government agencies, remember, that will more often than not be double checked and verified, who will be more reliable than a certain group or individual or organization who's trying to push an agenda. The second example is the effect of logging on the population of a species of bird. Should I go to a pamphlet from a wildlife protection organization, or should I go to a forestry company's website? Which one am I going to get more reliable information from? You want to think about what role, what point of view they have, what agenda they're trying to push. In this case, both could be one-sided, and so it's best to read both. Inform yourself by looking at all points of view, because they will most likely both give wonderful arguments for or against depending on their point of view, but together can give you a well-rounded picture. There's another example on the board, and if you want to try that one, you can go ahead, but I'm going to move to the next slide to make sure that we get it all in. We talked a little about surveys and questionnaires, and now I want to throw in polls. Polling companies, polls as in P-O-L-L, not P-O-L-E, if that helps verify for those who are not following along watching my slides. Polling companies conduct interviews with randomly selected Canadians to determine their opinions about a variety of topics. These surveys are called polls. When you are looking at polls, the results of polls are often reported in the media, particularly during elections. That's when the media loves to come up with these polls. We want to get an idea of what the public is thinking. Poll results usually will state a margin of error. This margin of error describes how reliable the data are. If you're sitting at home, you're watching the news, you're reading it online, it's coming across some platform or another, and you see a poll, look for that stated margin of error. It might look like this. On the board in front of me, I have the results of a poll conducted by ECOS in 2005. The poll was Canada should increase its humanitarian aid to poor countries, even if it means less spending in other important areas. It's a bar graph. We have results from August 2005 and January 2005. There's a portion in dark blue that tells us those who disagreed, a portion in light blue or gray that says they didn't have an opinion one way or the other, it was neither, and then we have this portion in like a peach beige that says they agree or disagree. Part A of this question says, what question were people asked? So if we look at it again, Canada should increase its humanitarian aid to poor countries, even if it means less spending in other important areas. So people are being asked whether they agreed with the statement, Canada should increase its humanitarian aid. And they were given a rating scale, because we can see here there's a disagree 1 to 3, a neither that says 4, and agree 5 to 7. So when we talked about rating scales last week, there would be maybe 1 was strongly disagree, and then there was 2, 3, 4, 5, 6, 7. So 4 was in the middle. That was our neutral. and then 7 would have been strongly agree. So they polled these individuals. They asked whether they agreed with the statement Canada should increase its humanitarian aid, and then gave them a rating scale of 1 to 7, with 1 being strongly disagree and 5 being strongly agree. They tallied up all of the results and put them into this bar graph. Part B says, how did the favorable responses compare in January to August? So what were the favorable results in January, and then what were the favorable results in August? So if we're looking at this bar graph, January of 05, favorable means those who agreed. We can see that in January 05, agree is that peach beige color, and it's 31%. Then they released the poll again a few months later and asked in August of 2005. In August of 05, they asked the same question. This time, they got a favorable result of 43%. So we can read that there was a change in responses over a couple of months, and that they increased. So you can go back and you can look up, well, what happened between January and August? Was there some event that took place that made people shift their thinking and say, yes, we should increase humanitarian aid to poor countries? You can tell a lot by people's responses based on their reactions to what's happening around them. It can be what's happening in their lives, what's happening in the news, what's happening around the world. And you can usually pinpoint, if you're somebody who plays with stocks, you can see how it spikes and decreases depending on certain events, how they can be affected by what's happening around the world. You see these huge spikes, these increases, and then decreases depending on crashes and natural disasters and different things. Now, what I really want to focus on, it says there's a line below the graph that states the results are valid within a margin of error of plus or minus 2.5 percentage points. That means that 19 times out of 20. Now, did I include that? Oh, I did not extend the graph to actually show that. Sorry, team. There is another picture where it has this, the results are valid within a margin of error. So it's letting you know that if or when this were to be conducted again, that the chances of it being replicated are 19 times out of 20. These are saying that if you took another poll, there is a 19 out of 20 or a 95% chance that the results would be within 2.5%. So that is an average somewhere between 40.5 and 45.5% of people polled would agree with the statement. This speaks to its validity. It's telling us that there is a small margin of error. When you see that margin of error, and it will often look like this, and again, I apologize that it's not on there, that I didn't include that second one, but you'll often see underneath a line that says margin of error. Excuse me, margin of error, and then you'll see this plus minus 2.5%. So if you see that, it's telling us that 19 out of 20 or 95% chance that the results would be within 2.5%. That's a very small margin of error. That is a very good, reliable, valid test if it can give you a margin of error of just 2.5%. As we have 5 minutes left, I'm going to run through the last of these examples because we are looking at statistics in the media. If you are on page 12 of your Unit 3 material, you can see how media is a business and increasing its viewership or readership is the goal. Knowing how to interpret the information regardless of how it is presented is an essential and valuable tool. So here we have some examples of statistics in the media. Knowing what we know based on what we learned last week, we have this percentage of Americans that how you can read a graphic, what you can gain from it. So the graphic that I have on the board is how it's presented in the news. And like we said, it is often pushed so that you are thinking like they think. They're really trying to drive their point home. So the graphic I have on the board, Fox News is saying we used to be an enthusiastically Christian nation. And they have this graph that says percentage of Americans that identify as Christians. In 2009, it was 77%, but when polled again in 2019, it was only 65%. So there's this drop. They make it look very significant because they are pushing a point of view. They want to see, oh my gosh, it's so drastic. We used to be an enthusiastically Christian nation, and now look at how few people are identifying. But we know to be careful and to read the graph as a whole. First thing we want to do is look at that y-axis. We want to look at that scale. Yes, it's true that there is a decrease. We're not denying that. But if we look at our scale, our y-axis starts at 58 and goes to 78%. If we were to have this go down to 0, it would be way more. And when you're looking at that much more data, then it doesn't seem quite as drastic and zoomed in. So it's not wrong, it's just definitely saying one way or another. Back in 2012, I tried to not make it so relevant so that we don't get into these hot, heated discussions. But again, usually during politics and runs like that, this is when we get a lot of this statistical information coming at us from the news. And so here the 2012 presidential run has a 3D pie chart. And we know from last week, when you put things in 3D, it starts to distort the reality of what we're actually being shown. You can show the same thing on a flat 2D circle, but when we're trying to push something, we will often make it. There's a lot of research on what color is more appeasing to the eye, which people are. Red is usually warning, bad, evil, and green, blue, yellow, like there's these happier colors as opposed to these dark colors, and sometimes we have to be careful with just the color choice, let alone how you're doing it. When you're putting a certain statistic forward on a 3D graph, making it appear bigger or so that your eye sees it first, can distort the reading. So we have to be informed so that we can know better. There are lots of examples I've got here in print. This one I thought was really interesting because it's upside down. I just want to highlight the y-axis. Usually it goes from 0 on the bottom up, but this one has 0 on the top going down, and it really distorts the information that you're reading. Things to be aware of the stats in science, stats in the news, stats. I encourage you to look at some stats that come across your screen this week and be critical thinkers. See, how are they presenting it? What are they trying to tell me? What agenda is being pushed or point of view? That's all the time that we have for today. Tomorrow we're going to pick up in lesson 13, which will take us 2 classes to do it. I hope you stay warm and have a lovely rest of your day.